How many degrees in a half circle?
180.
180. How many radians in a half circle?
Pi.
And then from there we went to what section 4.2?
Unit circle.
Unit circle. Woo-hoo-hoo. What were you supposed to be studying over break?
Unit circle.
What are you possibly videoing for 30 seconds today before the end of the day? Come and show me.
The unit.
You being quizzed on the unit circle. Do you know the unit circle?
Yeah.
And we'll see another reason why as we go into 4.7. What was section 4.3?
Right triangle.
Right triangles. Oh my goodness, what was that? Trigonometry. Sokotoa and
Shoshikao.
Shoshikao. Close. Sokotoa and Shoshikao, right? What am I talking about?
Unit circle. 36.
Kind of unit circle is more how to find. Yeah, exactly. How many trig functions?
6.
6. What are the 6?
Sine, cosine,
Sokotoa, Shoshikao, and how to find them with a right triangle that has, what are the 3 sides of a right triangle from a given angle?
Opposite.
Good. Opposite, adjacent, and hypotenuse. And we did all sorts of things with words, without words, in degrees, in radians, who knows. Section 4.4, where did we go?
Trig functions of any angle.
Any angle. Any angle degrees, any angle radians, any angle something weird like question. Why is this weird? 8 pi over 3. It's not weird, it's over 3. It's more than 2 pi, but doesn't more than 2 pi question, doesn't that track back to another angle that we can use? 6 and 7 and 8. Second quadrant is a pi over 3 angle, either the chart or you guys need to study your unit circle. Keep going. What's section 4.5? Graphs of sine and cosine. Oh no, guys, help me out. What do they look like in general?
Waves.
Waves, right?
Wave.
Waving. Okay, so question: where does sine start? In the center, right? Sine starts in the center. Then where does it go? If it's a positive sign. Up, and then middle, and then question, what could make it look a little funnier or be somewhere else than where it normally starts? Yeah, we could have like horizontal vertical shifts, we could have horizontal vertical dilations, right? Do you remember how we did our handwriting lines and we got it to fit in between? And we had to figure out our first initial point and our period and cut it into fourths. Sinusoidal curves, that was section 4.5. What was section 4. Wait, where does cosine start? Top. Very similar idea. Very similar idea. But it just starts at the top instead. Unless it's a negative cosine, then where does it start? Okay, sorry. 4.5. What's 4.6? Oh, graphs of other trig functions. What was the first one? Do you guys remember? Starts with T and ends with an tangent. Nice. So, tangent. Do you remember what this looks like? Swoopy swoop, like an x cubed, right? But doesn't he have vertical asymptotes? The nice thing was he had 0, 0, and he swooped up and he swooped down. Anybody remember where his vertical asymptote? Pi over 2. Anybody remember where this one is? Negative pi over 2. And what was his period? 1/2 plus 1/2 is 1 whole pi. A little bit different than sine, cosine, whose period is 2 pi. Okay, anybody remember the second one we talked about? Tangent and cotangent. What was different about cotangent? He's kind of the opposite. He's going to be this way. And remember, any 0 of one function of tangent is going to be what of the reciprocal? What's 1 over 0? What was a 0 for tangent is a vertical asymptote for cotangent. Cotangent shifts and flips. Cotangent shifts and flips. So he had a vertical asymptote at 0 and at 5. What's his period still though for cotangent? We have 2 more graphs. But why am I not going to draw another graph and instead add to one we currently have? Cosecant and secant, what do? They bounce. Bounce off who? The mins and maxes of sine and cosine. So who am I graphing if I'm bouncing, well, first of all, I'm getting vertical asymptotes from the zeros of cosine. If I'm bouncing off cosine, who is that bouncing off cosine?
Secant.
Good. Bouncing off cosine is secant. Oh, that's a horrible marker. Who's bouncing off sine? Cosecant. You draw my little asymptote though. So remember, vertical asymptotes are at the zeros, and then bounce, bounce, bounce. I need one more zero. There we go. Bounce, bounce, bounce. Now, this looks super complicated, right? But do you guys at least kind of remember what we did to get these 6 graphs? Sine and cosine, the handwriting lines, amplitude, sinus with axis, all that jazz. Tangent and cotangent, they had a middle point, they had a general shape, and they had vertical asymptotes. And secant and cosecant, how would you summarize what we do? Bounce. You bounce off sine and cosine. That was section 4.5 and 4.6. Where are we now? 4.7. All right, kiddos. This was the last thing we talked about before break came. We talked about how inverses, remember we did the whole snaky thing? Inverses flip, right? But why is flipping the whole thing a problem? Why can't we just say, oh, all these are possible answers? Were you supposed to pass to have a function? Vertical. The original has to pass the horizontal, which would mean the inverse passes the vertical, and does this one pass? So what do we have to do? Cut it down. Cut it down. And so we were just starting to talk about how there are restrictions for sine inverse. We're only looking for angles in the first quadrant and the fourth quadrant. Up 90 and down 90. Up pi over 2 and down pi over 2. For sine, to make it work. For cosine, can we not talk about cosine? Oh, we didn't. Okay, here we go. Then we talked about if a normal sine says, give me an angle and I'll give you a, who's this again? Give me an angle, I'll give you a ratio of sides, but which sides? Whose side again? Sokotoa? Give me an angle and I'll give you an opposite over hypotenuse. So, right? So this one is an opposite over hypotenuse. Give me an angle, I'll give you an opposite over hypotenuse. Sine inverse says, no, 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 give me an opposite over hypotenuse and I'll give you the angle. We're going backwards. That's what you're supposed to be studying in unit circle. So down here, let's recap A and B. Try C and let you guys play in your calculator with D for a second. But first of all, A. Why do I have pi's in my answer? We're finding the angle. Good, we're finding the angle in radians. Could have been in degrees, but we were doing it in radians because we guessed that's what they wanted. This arc sine means the exact same thing as what? Sine inverse, sine inverse. Because when you say -1, you think reciprocal. Is an inverse a reciprocal?
No.
Okay. So sine inverse or arc sine say, let's go backwards. So in your unit circle, you have to ask, when is sine -1/2? And we figured out sine is negative. If you need to, zero in on the quadrant. Sine is negative in all. Nope. Students, nope. Quadrants 3 or 4. In quadrants 3 or 4. When is sine 1/2? If you look in your table, it's going to be at the 30-degree one. If you look in your unit circle, it's going to be in the over 6s, the pi over 6s. Now question, why did I not write 5 pi over 6 or 11 pi over 6? Why did I instead write -pi over 6?
Sine is only for quadrant 1 and 4.
You guys hear him? Sine inverse is only allowed to have what as answers? Oh, the quadrant. These angles. If you need to think about them in degrees, they're only allowed to go up 90 and down 90. Positive 90 degrees and negative 90 degrees. I'm not allowed to go anywhere else for my sine inverse values.
So you only have one quadrant to work with, and you always have negative.
Because one's a positive quadrant, one's a negative quadrant. So you only have one answer. Remember, the whole point of restricting is to basically make it uniform so that we're all finding the first initial answer. Okay. So then, my only option couldn't have been going around to 5 pi over 6, couldn't have been going around to 11 pi over 6. I had to do the short, sweet, down pi over 6. Down. Down, negative. Now, what was the next one saying? Okay, sine's a positive. So question, is that going to be in quadrant 1 or quadrant 4? If I can only choose those two. It's going to have to be in quadrant 1. Where is sine root 3 over 2? Table people. It's going to be at 60. Unit circle people, it's going to be where? Pi over 3. Careful. Sine is the y, so when is it the top? Pi over 3. Pi over 6 is the little one. Pi over 3, 1/3 is bigger than 1/6, right? So I had pi over 3 as my only possible value. I had to go straight there, and we're done. Now, what about letter C? That's one we didn't get to. The only way you can do this without a calculator is if it is a value that's in the unit circle, that's as a y or as a sign in the unit circle. Guys, what are the 5 different special numbers that show up? Don't worry about signs, just the numbers. 0, 1/2, square root of 2 over 2, square root of 3 over 2. So first of all, is that unit circle? Oh, cool. All right, let's go to our calculators early. Plug and chug. Sine inverse of 2. How do you do sine inverse? It's not copyright. Second sine, right? Second sine 2, go! And the answer is? Did anybody work?
I got it.
Uh-oh. Come on.
Oh, I had one answer. And I'm in radians.
No, sorry.
Oh, my bad.
Sorry, this way. This one. Okay. Why doesn't it work?
Because then that point when it crosses over again, we grabbed it. And since we restricted it,
It's not because of the restriction. It's a good idea. It's not because of the restriction. But it's because of the domain. We restricted what angles come out. We didn't restrict what goes in, but what was restricted to
Whoa.
begin with.
But you cannot have your opposite be larger than your hypotenuse, so you gotta be less than 1.
Yeah, think of a right triangle, cool kids. If we had a right triangle, who's the longest side? Hypotenuse, right? So if I know the hypotenuse is the longest side, and if we say sine of theta is equal to opposite over hypotenuse, well, if that's the biggest number, can this ever be bigger than 1? That has to be the biggest number. So sine always, oh, that's right, in the unit circle, what's the biggest that sine can go? What's the highest it can go? 1. Now, it can go negative also, -1. But can it ever get to 2? Sine only goes up to 1 and down to -1. So sine inverse can only have numbers up to 1 and it can only have numbers down to -1 because nothing higher will work. Think about our 5 special values in our unit circle. Not only do they give us 5 special ones we can answer, they also tell us how low, how small as a number sine can go, 0. And how far away from 0 it can go, which is 1, which can go +1 or -1. But it can't go to 2. If you want to test me, go ahead and plug in some other number greater than 1 or less than -1. And everybody should get what as a result? Sine inverse of, go ahead, you individually pick some number bigger than 1 or less than -1.
You can have -2 either.
Can't have -2, can't have -10, can't have negative. Shout out some other things you're plugging in. Yep, 3 doesn't work. What else?
1.1.
1.1 doesn't work, 1.01 is not gonna work, negative 1.0001. What?
379 doesn't work.
379 doesn't either. Why? The only numbers that are gonna work in sine inverse have to be in between what and what? -1 and -1, and that's it. Okay? So hold on, since you're using your calculators, is this supposed to? Yeah, why? Because he's, less than 1 and in between 1 and -1. So this one should work. Go ahead and plug them into your calculators and let's see how many different answers we get. Wait, what? Aren't you supposed to get 1? 1 plus 1 is 2. 2 times 3 is 6. Different modes, yeah, that can make a difference. Someone tell me what answer you get.
0.268.
0.268?
2682.
Okay, we'll go around to 3 then. Did anybody get another answer? There should be one other possible.
Even out of degrees?
It's 15.37.
Oh,
Well, 66.
6, okay. Question,
but then you can have one.
how do you know who's who? One's in radian and one's in degrees, and just looking, what would you guys guess? Yeah, I would guess so too. And this would be, remember, radians aren't a label. Question, how can you tell from your calculator which answer you're getting? Go to your mode and then, check, are you in radians or are you in degrees? Question, are both of these right? Yes. How can that be a dilemma, like if we come to a quiz or test if 2 answers are right and it's like a multiple choice question, which usually only has,
Degrees should have a little circle.
check and see if all the answers have little circles or not. If they have little circles, what mode had you better be in? Degree, and if they don't have little circles, it's understood to be. But you have to understand that whenever you see sine inverse, you need to know what are you finding as your inverse, as your answer? Angles. Okay, so you have to know it's angles. Just keep an eye out. So that's only sine. Who else do we have? Okay, we're gonna go quicker with cosine and tangent because you've gotten at least kind of the idea of inverse. It's going backwards. We're just going to figure out, because remember, sine only worked for up to quadrant 1, down to quadrant 4, up 90, down 90, up pi over 2, or to negative pi over 2. So we need to figure out what's legal for cosine and tangent. I'm going to go kind of fast. Cosine starts at the top, right? Sine starts in the center. Cosine starts at the top. We're reviewing our little graph at the same time. Tangent starts in the center. And has a little vertical asymptote dings. Not labeling everything, I'm just giving you the idea. What does inverse do?
Well, it flips across the y-axis.
It flips it
No, across the y equals x.
across the y equals x line, right?
Yeah.
But do you guys remember what happened with sine? It was going around the x, and what happened when we flipped it? It started going around the y instead. Same thing with cosine. So to keep it legal, instead of starting away on the y, you start away on the x. And basically, you go right, middle, left, middle, right. It's very similar to up, middle, down, middle, up. The question, is that good or bad? Bad, because it fails the vertical line test. We have another domain problem. We'll get back to that in a second. Let's flip tangent 2. It's going to look a little funny, but maybe you guys can kind of see him flipping across the y equals x. Flip, 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 flip. People are walking upstairs. Little elephants. Okay. Isn't that a good one? No, what's wrong with tangent 2? So we have to cut both of these as well. And just to make it a little bit shorter, let me cut it up here so you don't have to draw the whole graph again. We have to make sure we can go as right and as left as possible. We have to make sure we get all the domain that we can. And for cosine inverse, we're going to end up with this little part right here, which is between 0 and pi. If we were to totally break this down. Between 0 and pi. Domain, cosine, just like, we'll say cosine inverse. Just like sine inverse, he's only allowed to have values between 1 and -1 because he is bound by the same thing sine inverse is bound by. Cosine is adjacent over hypotenuse. That can never be bigger than 1. Hypotenuse is the biggest. The denominator is the biggest number. Range is a little different than sine inverse because for cosine, we're going between 0 and pi instead. We'll come back and draw a picture to try to help you with what that means. So let's get tangent inverse first. I'm only allowed to take one branch of tangent inverse. He's going to go as right and as left as possible, so I'll get all of the domain I need. But he won't fail the vertical line test, which means he'll be an okay as an inverse function. Remember, functions have to pass the vertical line test. Tangent, he's cool.
Why doesn't he go under 0?
He does go under 0. Do you mean like this way? Or why doesn't he?
You put the range, it starts at 0, and he goes to pi.
Because if I did keep going, he starts to fail. Remember the vertical line test?
Well, yeah, it's just a...
Yeah, he can't fail, so I can't have a copy. I can't have anything copied for inverse cosine. Or tangent, I can't have, for inverse tangent, I can't have any copies. I have to just take one piece and stop. So how high and how low does tangent go? Is vertical asymptote down and is vertical asymptote up. Now, for some of us, it's going to be better if we can think in the unit circle terms. 0 and pi. We're only looking for inverse cosine. For answers between, guys, 0 and pi, what quadrants am I allowed to look in? Yeah, I'm only allowed to look in quadrants 1 and 2. That's different than sine, right? I'm only allowed to look in quadrants 1 and 2. It's different than sine. Sine's allowed to look in quadrants 1 and 4. If you're thinking in degrees, you're only allowed to look between 0 and 180 for answers, for possible angles. Tangent, though, negative pi over 2 and pi over 2. What are those ones again? 1, yeah, 1's okay. Going up to pi over 2. If I go down pi over 2, where am I? 4. So I'm allowed to look kind of like sine. I'm allowed to look anywhere in quadrants 1 and 4 if you need to think about it, negative 90 and 90. So to be honest, guys, this isn't really stuff you need to memorize. It kind of just leads us up to our legal quadrants to look in. Okay? Our legal quadrants to look in. Sometimes for an answer, there are lots of different solutions, but there are only maybe a limited number of wise solutions, right? Or legal solutions, same thing here. For inverse trig, we have to stay legal. So let's go ahead and see some examples, but, sorry, let's get to, you guys can get anything else down?
So we're probably not going to have to draw.
You won't have to draw inverse trig, but some of you knowing what the picture looks like might help you know the numbers for the restrictions, but others of you, this is enough, and you won't have to worry. So it just depends. Some of you, it might be helpful to write these down so you know what answers you're looking for and what numbers are allowed to go in. But for others of you, maybe just knowing the quadrants, that's where you're looking for different angles that fit what they're asking. So, the nice thing is, this page lets us know that inverse cosine and inverse tangent follow the same pattern as inverse sine. I'm going to actually get rid of this example and we'll do a couple others. I think that might be helpful. But if we have y equals Cosine inverse, remember that's the same thing as arc cosine. They're not two different things, they're the exact same thing. Same thing with tangent inverse. Whether it says tangent inverse or whether it says arc tangent. Oops, I forgot my C. They're the exact same thing. Just two different ways of saying it, and our book shows both so that you can kind of get used to both. But remember, what you put into cosine is an angle. What you get out is a ratio. Bless you. What you put into tangent is an angle. What you get out is a ratio. That's normal cosine, normal tangent. You have to remember, for inverse, it's backwards. They're going to give you a ratio, an adjacent over hypotenuse. And as long as it's legal, you're going to be able to find an angle within its restrictions, which are 0 to pi. And for tangent inverse, they're going to give you a ratio. You're going to have to, as long as it's a legal ratio, which for tangent, it can be anything, so it's okay. He's not bound, like sine and cosine. You're going to be finding the angle. But just remember, for cosine inverse, the angle has to be between, if this helps, we'll write it one more time, 0 to pi, if you're in radians, or 0 to 180 if you're in degrees. And for tangent, theta has to be in between negative pi over 2 to pi over 2 in radians, or negative 90 to 90 in degrees. Oh, I think I wrote my remember up above. Sorry, that was in the remember spot. Let's get done. You can put it down here, guys. Is there more room? I'm going to go ahead and write a couple examples so we can think about it, okay? I'm going to write a couple examples. Let's see. Let's do arc cosine of negative root 2 over 2. I'll just do one each of these guys. And let's do tangent inverse of negative root 3. And then for our example down here for our calculator, let's do cosine inverse of 1.5. And let's do tangent inverse of 1200. Okay. Which of these can we use the unit circle for? The top ones, right? Okay. Arc cosine. Where are we allowed to look for him? What quadrants? What angles?
Is it 1 and 2?
Yeah, quadrants 1 and 2. We're only allowed to look between these values. No question. Where is cosine going to be a negative number? Quadrant 1 or quadrant? Good. Quadrant 2. Which angle has root 2 over 2 with a cosine? 45s. 45s. What angle is a 45 right here in the second quadrant?
3 pi over 4.
3 pi. Wait, that's legal? Yeah.
Or 135.
Yeah. We're allowed to go between 0 and pi. We're allowed to go between 0 and pi. What angle would that be in degrees? 135, right? Now tangent. Remember, we're looking for cosine in these two quadrants. Tangent, what two quadrants are we looking for him? 1 and 4, right? Where is tangent going to be negative, 1 or 4? 4. Okay, do you remember when tangent goes with root 3? Square root of 3 over 3, 1 square root of 3. Hey, he's the 60 degree, right? 60 degree. Who's the 60 degree down here? Remember, I have to go negative.
7 pi over
It is 5 pi over 3, but that's illegal.
Negative.
But we can go negative.
7 pi over 4. Oh, it's negative.
Now remember, we can't go the big way and get the 5 pi over 3. We're going to go the short way. Negative pi over 3, or negative 60 degrees. Because we have to stay within our range. Kiddos, in your calculators, plug in cosine inverse 1.5. Let's go in degrees just to be able to visualize. Nobody shouting out answer cosine inverse of 1.5? He's bigger than 1. He's bigger than 1. Now, how about tangent
What a
inverse
trick.
of 1200? You're going to tell me none, but plug it in, remember?
Yeah, that works.
Tangent.
It's tangent.
Tangent's
Doesn't have a
not found.
hypotenuse.
What'd you get?
89.952.
89.952. That was in degrees. Is there a radian answer? I'm sure there is. Is that your bell? The bell's dying.
Guess so.
It started from the break too.
Yeah, is it tired from the break? Kiddos, we might peek at a couple homework helps, but you guys can do most of homework tonight. So we might have a half day on 4-7 to finish tomorrow. We'll do a half day of 4-7 tomorrow and a half day of 4-8. Bye, guys. I did meet your mom. Where was I? Oh, I did have her. I couldn't remember.
Did you get my test back?
She was bragging.
I don't remember getting my test back.
With
But
the
I remember
corrections?
I didn't have to do corrections because I got everything.
They'd be in the folder.